All right, pre-calc, we're going to continue working with our triangles. This time we're going to get into some areas of triangles instead of just finding out all of our angles and sides. The one thing that you know definitely from geometry, 1/2 base times height, probably definitely before geometry. So what we're going to do now is we're going to take a look at some specific parts here to deal with this side angle side. You see it's highlighted. So I might be missing some information, but I can still get through this. And here's why that works. So if I have side A, I have side B, and I have angle C. Now, what I'm not always given is the height here, but what we're dealing with is the hypotenuse as we make this right triangle, and we're solving for the opposite. Okay, so opposite hypotenuse is going to come from so, which is the sine. So it's actually the sine of C, and that's why you see it listed in here is we're going to deal with side H and side A. So we could do some substitution and we can work through some of these. All right, so side angle side, and here's really what's going to happen. So here it is in formula form, 1/2 1/2 side side and the included angle. So side angle side again is what we're trying to deal with here. So in normal terms, right, 1/2 side times the other side times sine of the included angle. So let's take a look at it as we put that together. Okay, so we're going to continue giving some of the same type of triangle problems, except for we're going to take out different information. So it's all based on what you have and what we're asking for, right? The key today is I'm asking you for the area. Okay, so we need to do a little bit of work to get there. So here's what I have, ABC, and I have side A is 12, side B is 20, and angle C is 35. So if I want to find the area, I have a side, an angle, and a side. So it's 1/2 12 times 20 times the sine of 35. So we can plug all that in here. And we end up at 68.83, whatever the units are, since we're talking about an area. I want to make sure I mark it as squared this time. Okay, so whatever the units are squared, doesn't say anything either which way. So we're in pretty good shape. Okay, so this quickly snowballs to start talking about some different shapes. So we have a quadrilateral. Okay, and we have a diagonal, of course, because I want to find some triangles somewhere, somehow. All right, so let's call it A, B, C. And let's deal with AB is 16, BC is 12, and angle B right here in the middle is 115 degrees. All right, well, you know what we're about to do. So 1/2 12 times 16 times the sine of 115 degrees. All right, so we're going to find the area, and let's plug all this in half. So we're at 6 times 16 sine of 115. Okay, so let's go with 87.2. Now, what did we just find? We found the area of this triangle, but the question isn't asking for that, is it? Find the area of the whole thing. So what are we going to do? All right, we're going to multiply this by 2. So we're going to double it up, and we're like 174, and no units again, so units squared. All right, so we can use it to chop things up as much as we need to. Okay, so that's using side angle side. All right, there's one more situation we're going to deal with today, and that's when I give you 3 sides. Okay, so there's a new formula today, kind of a big deal. Get an extra formula going on. So if you know 3 sides, can I still find the area? You're like, no, you just told me I had needed 2 sides and an angle. Well, if I had 3 sides, I can find out an angle, but there's a different way as well. Okay, so we could almost set this up so we can prove it in 2 different ways. Okay, so we have Heron's formula. We're going to get there, but to use it, we also have to identify what in the world is a semi-perimeter. So we have to find that first. So what is it? The semi-perimeter is half the perimeter. Okay, now keep in mind we started with 3 sides, right? So if I just add those sides up, that's what you see here, and take half of it. Now this is the way it's presented in the textbook. Personally, if I see it like this, I'm like, all right, that's cool, right? These are the same thing. So if that's the way you want to see it, Right, we're going to add the sides. We're going to take half of it. So either way, visually, I thought that was a nice way to see it. Okay, so that's going to give me the semi-perimeter. And we're like, great, because they asked for the semi-perimeter, right? No, they asked for the area. So what do I do with it? Okay, so once I know that, right, S is right here. So here's my semi-perimeter. So I'm going to plug it in. And notice what I have to do is I'm going to take the semi-perimeter times the semi-perimeter minus each of the sides separately, multiply all 4 of those together, take the square root, and that will give me the area. Okay, so let's get one sketched out here and see what happens. All right, 12, 10, 8. Okay, well, that was great and all. Now notice I didn't label A, B, and C as far as sides. It really doesn't matter for this one. Just want to have all those things in here. So first thing I'm going to do is find out what's the semi-perimeter. So that was 12, 10, and 8. I'm going to take half of that. Okay, so we add those up. I get 20 here, 10 more is 30. Half of 30 is 15. So S equals 15. So now we're going to use the actual formula. So big square root, I need 15 times 15 minus 12 times 15 minus 10 times 15 minus 8. Okay, so let's get all this together. So 15 times 13 times 5 times 7. I'm going to take the square root of that when I'm all done. So it turns out to be 1,575. That's the number we're going to take the square root of. And again, do we have anything there? No, no unit. All right, so as I take the square root, I'm at 39.69. And again, we're at units squared. Remember, anytime we're talking about the area, the unit is important, that we're going to have that squared. So if there were inches, inches squared, centimeters, centimeters squared, kilometers, kilometers squared. Okay, so those are our 2 things for today. So side angle side and side side side. We're going to continue rolling with these triangles, and I'll see you in class.